In this lesson, we're going to look at an introduction into exponents and explore a few of the laws of exponents. Now, exponential notation is used to express repetitive multiplication in a more efficient manner. So as an example, I have the number 7 being multiplied by itself 4 times here. Using exponential notation, we will write this as 7, and then how many ever 7s are being multiplied, that will be the exponent. And so if I examine this expression a little more, the exponent is always going to be in the upper right-hand corner, and the number that the exponent is being applied to, that is called the base. So how do we multiply exponential terms? Well, when the bases are the same, we're going to copy down the base and we're going to add those exponents together. So if I look at this first example, I've got 3 terms of x being multiplied. So their bases are the same, so I'm going to copy down their bases, and I'm then going to add their exponents. And so 3 plus 4 plus 6 is going to be x to the power of 13. One more example. I've got 3 terms of x. They all have the same base of x. Now, this term over here looks like it's missing an exponent, but if there is no exponent, it's understood to be a 1. So I'll use my laws. I will copy down the base, and I'm going to add the exponents. So we're going to get negative 3 plus 4 plus 1. Negative 3 plus 4 is going to be 1, and then 1 plus that 1 is going to be x to the power of 2. How do we divide exponents? Well, if the bases are the same, we're going to copy down the base and we're going to subtract the exponents. So these y's, they are the same base, so we are going to copy down the base and we are going to subtract the exponents. 8 take away 5 is y to the power of 3. Now, why does this work? Well, if I were to expand, what does y to the power of 8 look like? It looks like 8 y's being multiplied out in the numerator. And then in the denominator, y to the power of 5 is going to be 5 y's being multiplied. Now, we're just going to start dividing. A y will divide with a y to give me a 1. This y will divide with this y to give me a 1. There will be another 1, another 1, and another 1. And when I look, what am I left with? I'm left with 3 y's being multiplied, but we now know that exponential notation can be used to represent that repetitive multiplication. Looking at this next example, we have some x's and y's all being divided. So I'm going to copy down the x, and I'm going to subtract exponents. So 9 minus a minus 2. And then the y's are going to be 12 take away 10. Now, 9 subtract a negative 2. Remember that subtracting a negative is the exact same thing as adding a positive. And so that'll be 9 plus 2, which is going to be x to the 11th power. And then for the y's, 12 take away 10 is going to be 2. The next law we're going to look at is an exponent to another exponent. This is also sometimes called a power of a power. And the rule for this is that we're going to multiply all the inside exponents by the outside exponent. Now, why this happens is if I have y squared to the power of 3, well, we know that that to the power of 3 means that we have 3 of the bases being multiplied. Then we're multiplying, so we add the exponents together and we get y to the power of 6, and we can see that 2 times 3 is going to be that 6. So extending that to this example here, I have an exponent on the outside, and that is other exponents are being raised to that. So I'm going to copy these down and I'm going to multiply all the exponents by the outside. So on x, 3 times 5 is going to be 15. On the y, remember if there's no exponent, there's a hidden 1 there. So 1 times 5 is 5. And then finally for the z, 8 times 5 is going to be 40. One last example with this law, we've got 2b to the power 5 all to the power of 3. Now, the most common mistake on this one is that people forget that there is a 1 on that 2. So this will be 1 times the 3 will be 2 to the power of 3. And then that will be 5 times 3, so 15 on the b. And then we could expand and simplify. 2 to the power of 3 is going to be 2 times 2 times 2, which is going to be 8b to the power of 15. Now, just to show you why we often mistake that 2 to the power of 3 and we forget it, remember that this repetitive multiplication means take the base, which is 2b to the 5, and multiply it 3 times. Well, if I do that, I can see that 2 times 2 times 2 is going to be that 8 that is in the final answer. Looking at a few more complicated examples now, putting some stuff together, I'm going to look at this expression to simplify right here, and I'm going to do it 2 different ways. The first way I'm going to do it is just by noticing, hey, I have an exponent to a power of an exponent, so I'm going to multiply all of my outside exponents, so remember that there's a 1 there, by the inside exponents. So 2 times 3 is going to be 6, and then 6 times 3 is going to be 18. All divide by, and then that's going to be 3 to the power of 3 because there's a hidden 1 there. There's a hidden 1 on that x, so that'll be x to the power of 3. And then on the y's, 2 times 3 is going to be 6. I'm just going to simplify the numbers here. So 2 to the power of 3 is 2 times 2 times 2, which is going to be 8. And then this is x to the power of 6, y to the power of 18. And then the denominator, 3 to the power of 3 is 3 times 3 times 3, which is 27. And then this is x to the power of 3, y to the power of 6. Now, I'm done all my exponents, but I now have division. And the 8 and the 27, they're not going to reduce. So I'm going to leave that as 8 in the numerator and a 27 in the denominator. But if I look at the exponents on the x now, they're the same basis, so I can subtract those exponents. So I'll have 6 take away 3 on the x's, and on the y's, I'll have 18 take away 6. And so my final answer is going to be 8x to the power of 3, y to the power of 12, all divide by 27. Now, I also could have chose to simplify what was inside the brackets before applying the exponent. So I'm going to do that in this example just to show you that I get the same result. In the numerator, I'm just going to be left with a 2 because the 2 doesn't simplify with that 3 in the denominator. Looking at the x's, there's a hidden 1 there. So copy down the base. 2 subtract 1 is going to be a 1. And with the y terms, I'm going to have 6 take away 2, which is going to be 4. And then all of that is raised to the power of 3. We now have a power to a power. So the 2 is going to get the exponent of 3. The x, 1 times that 3 is 3. And then 4 times 3 is 12. All over 3 to the power of 3. And then if I simplify that, 2 to the power of 3 is 8. That's x to the power of 3, y to the power of 12 over, and in the denominator, 3 to the power of 3 is 27, which I can see I had the same answer up above. And the last basic law of exponents in this video is going to be an exponent of 0. And it says that any base that is raised to an exponent of 0 is always going to be a result of 1. And so let me show you why. Let's take x to the power of 4 divide by x to the power of 4, and we're going to do this 2 separate ways. So the first way is that we are going to use repetitive multiplication and expand this and say that that is 4x's in the numerator being divided by 4x's being multiplied in the denominator. Now we can start dividing to 1. This x will divide with this x, leaving a 1. This x will divide with this x, giving a 1. That divides to 1, and this x divide to 1. Multiplying that all out, we'll see that we get a result of 1. But using our laws of exponents, we now know that to divide, when the bases are the same, we subtract the exponents, which means that 4 take away 4 is 0. We can now conclude that x to the power of 0 is 1 because both of these started off being the same expression. So since they were equal to the same thing to begin with, therefore, x to the power of 0, where x can be any number other than 0, will be 1. So just 3 quick examples down here to make sure that that's okay. So 5 to the power of 0, if you put that in your calculator, that is the base of 5 being raised to the power of 0. That answer will be 1. Looking at the next example, -5 in brackets. Those brackets make that all the base raised to the power of 0. That result will be 1. Pause the video really quickly though and type in -5 to the power of 0, not in brackets, into your calculator. You'll notice that your calculator gave you a result of -1. And the reason why is because any negative number is actually -1 multiplied by the positive result of that integer. And so -5 all to the power of 0 is -1 multiplied by 5 to the 0. The 0 is only being applied to the 5, the term directly to the left, not to the -1. This then becomes 5 to the power of 0, which is 1, but that gets multiplied by that -1 out front. And that's why your calculator was giving you a -1 result.